Here we are into the practice problem videos, and I'm going to do two of them. I want to do one that has exponential growth and another that has exponential decay. But before I do that, I want to go over a practice problem. I mean, a sort of review problem of the kind of equations that we solved last week. Okay, so I want to solve 1 plus 0.3 divided by 4 to the 4t equaling 2. So I'm not going to bother to compute that out. And the way I'm going to do this is I could, rather than rewrite this as a log, I'm going to take logs of both sides. And I did that a bunch of times in last week's practice problems. So I'm going to take log both sides. As you remember, that will help me bring the exponent down to the ground so I can deal with it. Okay. Then I can bring this down using the power rule. Okay. And I'm going to have to get the t alone, so I'll rewrite this so we have it right in front of us. And again, I am not going to waste time trying to figure out what that equals because I don't need to. When I plug it into the calculator, it will come out. So I'm going to divide each side by 4 and each side by this. Okay, so divide each side by 4 and each side by 1 plus natural log of 1 plus 0.3 over 4. The 4's cancel, those cancel. So I'm left with this equation, t natural log 2 4 times natural log 1 plus 0.34. And when I plug that into the calculator, I get 2.396 rounded to 3. So what we're going to do today, since it's doubling time, is we're going to solve equations which look like this. A k times t or x equaling 2, doubling time. Okay, so I did something a little bit different with the practice problems. I uploaded them and printed them out. I think it just will be easier than me having to write them out. So the first one is going to be an investment problem. And investment problems are of this form. P of t equals p 1 plus r over n to the n times t. And remember that p is the money we start with. P is 1,000. The rate is going to be 10%. And as a decimal, that's 0.1. I move the decimal over twice. And compounded yearly means my n is equal to 1. So, and doubling, since this is doubling, I'm going to set that equal to 2,000 and solve it. So here we go. So I'm going to solve 1,000 times 1 plus 0.1 over 1, I'm not going to bother to write that, to the t, equaling 2,000. Now, I'm going to end up with that equation, of course, but I just wanted to go through this one more time. So you always divide both sides by what you start with. This is, in essence, twice what you start with, so that's always going to end up being a 2. So the equation I have is going to be 1.1 to the t equals 2. So I want to solve this. Rather than write that as a base, I'm going to take the logs of both sides. I'm going to use natural log today. I could use base 10. So I take the logs of both sides. I get 1.1 to the t log 2. That's going to allow me to bring the t down. So my equation now is t equals natural log 1.1 equals natural log of 2. And so I'm just going to divide, t times that equals natural log of 2. So I divide both sides by natural log 1.1. That cancels that. My equation is t, natural log 2, natural log 1.1. I've already worked out the details, and this is going to be equal to 7.272. I need my units, so my units are going to be years. So that's my answer. Okay. So the second one, it's another investment problem, but I'm not even going to bother to put the initial investment in because that's just going to cancel. So my rate is going to be 6%. Oops, let's make sure you can see that. Yeah. And that's going to end up being 0.06 for my R. Okay, my N is quarterly, so that means my N is 2. So my equation is going to be 1 plus the rate, I want to 0.06 divided by 4, the number of compoundings, 4 to the t, and that's going to be doubling, so that's going to be equal to 2. So I'm going to take logs of both sides again and bring the 4t down. So I'll do that, start with that over here. Make sure we can see it. Natural log 1 plus 0.06 divided by 4 to the 4t is equaling 2. Okay. Now this comes down, the 4t. So I'll rewrite it again. 4t natural log 1 plus 0.06 over 4 equals natural log 2. And I forgot to have the natural log 2 over here. I just left that out. Okay. So again, I want to get rid of this and this, so I divide each side by 4 and each side by this quantity, natural log 1 plus 0.06 divided by 4. So natural log 1 plus 0.06 divided by 4. 4's cancel, that cancels. My equation is now this, t equals natural log 2, 4 times natural log 1 plus 0.06 over 4. And again, I plugged this into the calculator and I ended up with 11.638 years. And that's my t. So I will box that off so it's easy to read. Okay. Sorry, I squeezed that a little bit. Okay, so the next problem is about disease, and the infection rate is 1.12. So that means that's going to be my exponential base. So that's going to be my A. We saw this in the similar problem when we first introduced these problems. And before the rate was 1.04, meaning that each person infected 1.04 people, but today the rate is 1.12. I looked it up on the web today. So I want to find out how long it takes for the number of people infected to double. Okay, so I set up my equation. It's going to be my rate, or actually 1 plus the rate of 12%. And then to the t equaling 2. And remember before an infection cycle is 5 days, so t equal 1 is 5 days. Okay, so I need to solve this equation. Take logs of both sides. Bring the t down. I'm going to divide both sides by natural log 1.1 t. Sorry, it's not there anymore. That cancels. This goes over here since I'm dividing both sides by that. So t is equal to log 2, natural log 1.12. And I got about, what was my answer to this over here? I wrote it down over here. There wasn't a whole lot of cycles. It was about 6.116 cycles. Each cycle is 5 days, so it's going to be 6.116 times 5 days. So when you do the math, that's going to be equal to 30.58 days. So if things continue as they are, we could expect the number of people infected on this day in a month to be twice what it is today. Okay, so those are my, let me move that over again. So these are the practice problems for exponential growth. and then I'm going to do another video for exponential decay. Okay, thank you.